Do you believe in hell or heaven? Regardless of belonging to a particular religion, such hypothetical places are present in the mindset of any believer. What does paradise, Valhalla, Elysium, Iaru, or Eden mean to you? Or maybe all of this is just made up and there is only one paradise for everyone. By the way, it's quite possible that this is exactly what the Hubble telescope discovered at the very center of the universe. This is what the dwelling place of God looks like according to the orbital device. If you look closely, you can even see streets and houses. Isn't this the intelligent civilization we've been searching for all this time? Scientists are still debating whether this is a fake or if humanity has truly discovered something frightening. Most agree that this is a photo of the Galaxy New General Catalog 3079 with a sparkling disk and a blinding light. But even if these amazing photos don't mean exactly what we would all like, it doesn't diminish the achievements of modern telescopes in exploring the macrocosm, including its most distant corners. For example, James Webb, the orbital infrared observatory that is already becoming legendary in the scientific world, is not just a telescope, the largest one available at the moment. It was created to revolutionize our understanding of the universe. After its discoveries, it might be time to throw away astronomy textbooks and the works of some scientists. Take, for example, the galaxies it discovered at record-breaking distances. These are objects with the codenames JDs, GC, Z14-0, and JDs, GC, Z14-1. You might ask, what's so amazing about this? Haven't other telescopes discovered distant galaxies before? Well, yes and no. The thing is, these objects, which appeared just 300 million years after the Big Bang, shone bright red through the eyepieces of the orbital observatory. This means that the galaxies are not just filled with mature stars, but also hide active black holes inside. However, this simply can't be the case if we stick to the traditional theory of the universe's origin right after the Big Bang. There simply wasn't any building material for the formation of metal-rich, that is, mature stars, so they couldn't have formed. As for black holes, according to the evolution of these dark, not fully studied objects, they appear as a result of the death of massive old stars. Obviously, this also doesn't fit into the coherent theory that several generations of scientists have believed in. What do such discoveries tell us? It means that we need to fundamentally review and revise everything because our knowledge is seriously outdated and has lost its relevance. What's frightening is that a huge number of fundamental scientific pillars are built on the Big Bang Theory, and if those are destroyed, it's hard to predict the consequences for modern science. So, what are representatives of the scientific community doing in light of these new circumstances? Research has already begun in this field, and scientists have found that the main ones are black holes. As a result, it turns out that these objects don't necessarily form from dying stars. They can be born immediately as huge and active. Astronomers call this phenomenon primordial black holes. Doesn't this seem like an attempt to artificially fit existing scientific data to new information? For those who have recently started watching our channel, it's worth clarifying the basics a bit. How do we know the distance to a star, galaxy, or black hole? How exactly do we measure the distance to incredibly distant objects using a tape measure, a ruler, a protractor? Of course not. We rely on the speed of a photon of light in a vacuum, and that's exactly why telescopes observe objects, not as they look at this very moment. A simple example, light from the sun travels to us for about 8 minutes, so we see the star as it was 8 minutes ago. It's the same with distant galaxies. It's remarkable that while the light from these objects, which are billions of light years away from Earth, is traveling to us, the galaxies themselves might no longer exist. It's quite difficult to understand, but that's the macrocosm. Many concepts in it don't fit at all with our usual ideas about the world. What else has James Webb managed to discover during this time? One of the most remarkable discoveries is planets located outside the solar system. It is noteworthy that we have either seen such objects indirectly or simply assumed that exoplanets orbit around some star. But James Webb made a breakthrough in this field and photographed the planet KIP 65426 for the first time. What might it look like? Presumably its size is 12 times larger than our Jupiter, and its age is about 20 million years. For comparison, Earth is 4.5 billion years old, so this object is quite young. The planet is located 385 light years away from us and orbits its star at a distance 100 times farther than Earth is from the Sun. Which other planet relatively close to us has also been observed by James Webb's instruments? This is a gas giant in the constellation Phoenix Wide-Angle Search for Planets, 96b. The telescope started by detecting a dense layer of cloudy atmosphere around the planet, and then went on to find undeniable evidence of water vapor in it. What does this mean in practice? The answer is obvious even to a non-specialist. It means that there could be water on the planet. You can figure out the rest yourself. It's amazing that the planet's mass is half that of Jupiter, but its radius is 20% larger. The temperature on this object is extremely high because Wide-Angle Search for Planets 96b is 9 times closer to its star than Mercury is to the Sun. Do you know the meaning of the word outcast? This concept can be applied not only to a person but also to a celestial object. Take, for example, the nebula New General Catalog, 1333 discovered by James Webb, thousands of light years from Earth. We've known about this object for a long time, since the mid-19th century, when the nebula was discovered by Edward Schoenfeld. Unfortunately, it was not possible to study it in such detail before, but James Webb has changed that. And what did we learn as a result? Inside the nebula, 6 objects are believed by scientists to have been meant by the universe to become stars. But something went wrong, and thermonuclear reactions did not occur inside these celestial bodies. As a result, the failed stars remained dark and cold. The 6 objects located in this nebula are currently gas giants, each 10 times more massive than Jupiter. Do you know how James Webb managed to leave the question open, literally in every sense of the word? The thing is, the telescope once discovered a huge question mark in space. The universe doesn't really like such configurations, so seeing them is a great stroke of luck, and James Webb was fortunate. This strange figure is most likely caused by a rare form of gravitational lensing, which is a phenomenon where the gravity of massive objects distorts the light of background stars. Do you know what it is? The paradox of this phenomenon is that in order to examine these galaxies in detail, Earth's scientists are actually helped by the universe itself. With the help of this process, the object discovered by James is about 7 billion light years away from us. The mentioned nebulae, galaxies, and other monsters are the most well-known among those discovered by this orbital station, but they are far from the only ones. For some time, James Webb observed our Jupiter, photographing its rings and auroras, Saturn and Neptune, as well as objects that, due to our technical immaturity, we couldn't see before. We're talking about the pillars of creation, which were first discovered by Hubble. This time, James Webb literally broke the object down to the pixel, revealing areas of gas accumulation and an amazing red glow in the background. The telescope also captured the process of star formation at its peak, recording the protostar L1527. In short, during its time in orbit, James Webb has more than justified both the investment in its construction and the expectations of the scientific community. However, it's worth asking what will happen to traditional astronomy next, especially considering new discoveries, such as galaxies in places so remote that these objects shouldn't exist there at all. Could it be that the Big Bang Theory is not correct? Maybe the universe didn't originate from the notorious singularity point, but, for example, as a result of a collision with an anti-universe. Or perhaps its emergence is cyclical, and our universe is simply one of many that periodically appear and collapse. It's also unclear how things stand with the distribution of matter in the macrocosm, and whether dark matter is really the main ingredient of galaxies. To fully answer these questions, the format of this video is definitely not enough, but we still want to draw your attention to one aspect. According to widely accepted theories, the cosmic microwave background radiation in the universe is distributed relatively evenly, but there are several anomalous regions in its vast expanse, such as the so-called axis of evil, which separates the warm and cold regions of the cosmic microwave background, as well as the Eridanus supervoid, a creepy place with a temperature close to absolute zero, incredible size, and unusually low microwave radiation. Both in the scientific community and among conspiracy theorists, almost everyone has talked about it. On the map of the universe's microwave radiation triggered by the Big Bang, on the remnants of which we now live, this cold region is clearly visible. It may have appeared due to the uneven density of the early universe, but that's not the only theory. Some physicists, yes, you heard that right, not conspiracy theorists, but physicists, believe that the Eridanus supervoid is nothing other than the imprint of a parallel universe, located beyond the one we live in. Whatever it is, sometimes sounds can be heard from there. Let's not make a myth or draw any conclusions, just listen. The discoveries made by the Hubble and James Webb telescopes, the juggling of theories and hypotheses, and the attempts to determine the laws governing the distribution of dark matter and energy, all of this is undermining the astrophysical postulates that orthodox science has relied on for a long time, day by day. That's why sometimes the question arises, is it possible that everything we used to believe in is just a statistical error or inaccuracies that crept into the calculations? Maybe everything? Where do these ghost galaxies, rogue nebulae, giant question marks, and other atypical objects come from? At the moment, the only conclusion we can draw is that modern physics has a huge number of unsolved problems. We hope that James Webb will eventually help solve them. Otherwise, we'll have to turn to the abode of God for help, although it's obvious that our pleas for help won't reach their destination anytime soon. Can you tell me the most sophisticated and expensive way to go insane? An ingenious plan, perfect for someone who has decided to end their life in the most spectacular way possible. No need to check the Darwin Awards top list. Those options aren't included. We're talking about the future flight of colonists to Mars. But why are we mentioning this great event in such a pessimistic way? Because optimism in this case is not only undesirable, but also fatal. The aforementioned one-way journey is unlike anything humanity has ever undertaken before. It holds dangers, the full list of which we are not even remotely familiar with compared to this cosmic adventure. Breakfast in a cage with wild tigers is an ordinary meal, but quite a prelude. For Earthlings, Mars is still the most suitable candidate for relocation. What difficulties await cosmonauts on the way to their desired goal? How much time will astronauts have to spend in deep space? Is it possible to solve most of the problems that arise during a long flight? And the main question, who will reach Mars first? Humans or beings with the intelligence of an eggplant? Let's try to answer briefly. Subtitles by Dimitorzak. So, why the red planet? This is the simplest question out of the many. The conditions on Mars are not exactly hospitable, but at least its clouds won't shower colonists with sulfuric rains like on Venus. A day here lasts almost as long as on Earth, and there are changing seasons, but the year itself is twice as long as on Earth. The weak gravity of the red planet also works in our favor. Launching ships from the surface will be easier. The thin atmosphere offers just a little protection from cosmic radiation. The conditions aren't paradise, but they're not quite hell either. However, let's not count our chickens before they hatch. A manned flight to Mars is still just a planned event, so let's focus on the journey itself. Do you know why we mentioned eggplants at the beginning of the video? Because the greatest and unfortunately not unfounded fear of scientists around the world regarding the flight to Mars is that even after reaching the red planet, astronauts may not be able to land on it. Not to mention establishing a colony and conducting scientific research. Why? Because after several months of flight, the crew members will turn into constantly vomiting patients in a dementia ward suffering from Alzheimer's disease. And this is not an attempt to scare you. Scientists at the University of California, Irvine, found through experiments on laboratory rats that prolonged exposure to charged particles, similar to cosmic radiation, causes irreversible cognitive impairments in the brain and malfunctions of the central nervous system. It is noteworthy that the rats were bombarded with charged particles for only 6 months, and the results of this exposure turned out to be extremely disastrous. And yet, astronauts will have to travel to Mars, possibly for 9 months or even longer. Why did we start with the cognitive sphere? Because radiation is the main danger threatening astronauts both in open space and on Mars itself. And it is precisely this that can primarily lead to the complete failure of the mission and the death of the crew. Space radiation affects not only brain function, it destroys the DNA of living organisms, causes irreversible mutations, and leads to a painful death. The effects of radiation on humans under earthly conditions serve as a distant example of such destructive changes. Remember the chilling consequences of the United States strikes on Hiroshima and Nagasaki, or the explosion at the Chernobyl nuclear power plant. But cosmic ionizing radiation is many times more intense. And we haven't even talked about the other problems of this extremely complex and deadly journey. You can draw an analogy with the first spacecraft that tried to land on the surfaces of neighboring celestial bodies out of ignorance. Engineers equipped them with insufficient protection and didn't take into account a number of other factors, as a result of which the probes perished either in the atmosphere or a few seconds after landing. But can a flattened tin can, even if it's not cheap, really compare to human lives? That's why scientists approach the organization of a manned mission to Mars with great caution. And preparations for it involve all groups of specialists, from quantum physicists to medical science candidates. How do scientists plan to solve the problem of radiation exposure? The condition of astronauts on the International Space Station cannot serve as a marker in this case, because they are protected from invisible death by the Earth's magnetic field. Logically, an interplanetary shuttle will also need protection. The crew will need medications that protect astronauts from developing cancer and other problems. Solar flares also matter. If even one major burst occurs during the flight, the radiation dose will immediately increase by an order of magnitude. In that case, the end of a manned mission to Mars could be the collective death of the crew from radiation sickness. However, there is also encouraging news. Scientists are not giving up and are looking for ways to protect astronauts on their difficult journey. A computer simulation has been created based on data from the Curiosity rover, where astrophysicists tried to model how shielding technologies would work in Martian conditions. The results were encouraging. It turned out that cosmic rays are effectively reflected by composites made of synthetic fibers, certain types of plastic, and rubber. But this still doesn't solve the problem of radiation during the flight, because you still have to get to the red planet through the void of space, which is filled with invisible killer particles. In any case, Research on producing effective composites to protect the interplanetary shuttle is ongoing. Next up are the anti-radiation vest from the Israeli company SteamRed, the high-efficiency particulate air radiation monitoring detector, and the development of a powerful electromagnetic field by specialists from the European Center for Nuclear Research. What helps scientists in their research? A powerful supercomputer, which also offers the concept of an active non-magnetic shield, meaning an electrostatic field. Right now, astrophysicists at National Aeronautics and Space Administration's Jet Propulsion Laboratory are working on it. What is the next problem facing future colonists? It's the lack of gravity. Again, the International Space Station crew can't help with this issue, since they're in microgravity, which only remotely simulates Earth's gravity. Gravity is one of the basic influences on the human body that determines how it functions. The absence of this invisible force leads to a drastic restructuring of all systems, starting with the cardiovascular system. In weightlessness, the heart has to work much harder to pump blood, which mostly flows to the upper half of the body. At this stage, a malfunction occurs because the brain thinks there is an excess of fluid in the body and starts releasing the appropriate hormones to solve the problem. But that's just the tip of the iceberg, a minor obstacle that can be solved by adjusting the drinking regimen. Things get much worse when the state of weightlessness becomes chronic and prolonged. That's exactly what awaits astronauts during a flight to Mars. When preparing the crew, it will be necessary to take into account the genetic predisposition of the crew members. Due to bone loss, which leads to bone fragility, in weightlessness, bones become porous and weak and muscles atrophy. Everyone has seen footage showing the arrival of cosmonauts on Earth, where instead of brave conquerors of space, helpless people return home who, like little children, have to learn to walk again. What does this imply? Obviously, it is necessary to create an artificial gravitational and at the same time, a magnetic field. The absence of the latter negatively affects the human autonomic nervous system. It also protects the surface of the celestial body or the spacecraft from ionizing radiation. Certain problems arise in this regard. For the magnetic field to be effective, its range must extend to 100 kilometers. In that case, the electromagnet would be so huge and massive that installing it would make the mission itself impossible. In addition to artificial gravity, specialists have developed alternative ways to protect astronauts, such as taking medications that reduce the risk of diseases caused by weightlessness. But what about the psychological barrier? Is it possible that under total cosmic radiation, Alzheimer's disease might not even develop? It's possible that a shuttle could reach Mars with a crew who have destroyed each other. The crew will be thoroughly tested for stress tolerance during a long journey in a confined space and for compatibility. But you still can't ignore the possibility of conflicts arising. The slightest aggression, like a match in an oxygen tank, will immediately trigger an explosion. On top of that, you have to add exhaustion, injuries, insomnia, and the inability to properly treat aggravated illnesses. And most importantly, the remoteness from Earth, which will be felt even more strongly the deeper the ship goes into space. And if the equipment suddenly picks up a strange sound coming from the void, how will the astronauts react to it? Let's leave that question open. What do scientists plan to do about the possible psychological problems of the crew? It is proposed to equip the shuttle with virtual images of changing seasons, to liven it up with earthly sounds, the noise of the sea, birdsong, and so on. What if we put into practice Aldous Huxley's scenario? Soma, a gram and no drama. In other words, There's nothing new about the idea of using tranquilizers. Back in 1983, a nootropic drug called phenotropal was developed for Soviet cosmonauts, which quickly restored cognitive functions and improved their psycho-emotional state. A first aid kit is mandatory on the International Space Station, and its contents include temporary fillings, antidepressants, nootropics, stimulants that increase physical activity and performance, and antiemetics. Obviously, the contents of the first aid kit for long-term space missions will be seriously revised and improved. The only thing that doesn't work in space is a mercury thermometer, but body temperature can be checked using the spacesuit, which monitors vital signs. Finally, we've listed all the problems during the flight. I wish I could say that, but that's not the case. What other threats await the crew of a ship that's leaving for Mars forever? Assuming the flight and landing go smoothly, the red planet itself won't welcome the colonists with open arms either. Mars is quite a hostile environment, not meant for humans to stay in without greenhouses and perhaps proper protection. Think about it. Mars rovers find Martian dust inside almost immediately after landing. What will happen to human lungs in such conditions? And how well will the equipment in the colonists' modules function? And that's not even mentioning it yet. About possible critical equipment failures, both during the flight and on site in extremely low temperatures. Mars averages minus 60 degrees Celsius, dropping to minus 150 degrees Celsius at the poles. It's a questionable pleasure to have to constantly wear a pressure suit, since the atmosphere on Mars is nominal at best, and its pressure is less than 1% of Earth's. In addition, despite the compensating effect of the thin atmosphere and regolith, the reactive radiation background on the red planet is 2.5 times higher than on the International Space Station. And this is another problem that the colonists will also have to solve right now. The Perseverance rover is testing the innovative Mars Oxygen in situ resource utilization experiment device to produce oxygen from the Martian atmosphere, which will be a great help for future missions, because if successful, it will support the operation of the modules. It is planned to install anti-dust filters to neutralize the destructive effects of Martian storms. Who is currently willing to invest in this venture? Which companies are preparing manned missions to Mars among the global projects? A century-long spacecraft that will land colonists on the red planet and then continue on to one of the star systems. Inspiration. Mars Foundation is a company planning a manned flyby of Mars, and Mars One is a rather risky private project that will broadcast what is happening. Of course, we can't fail to mention the ambitious plan of Elon Musk being developed by SpaceX. What do you think? Will any of these projects ever succeed? And when might that happen? What do you know about loneliness? Are you afraid of it? Or, on the contrary, do you desire it? If the second statement is true, then keep in mind that desires tend to come true right away. There is an object incredibly far from Earth that left our planet in 1977 and now knows everything about loneliness. And that's Voyager 1. At the moment, the probe is the most distant man-made object. No one has ever ventured into such cosmic wilderness. But by the standards of the universe, Voyager 1 seems as if it has just left its own doorstep. After all, the incredible distances it still has to travel are nothing compared to the mere 47 years of its flight. What would we see if the probe's cameras were turned on? What monstrous secrets could we uncover? To begin with, let's remember how it all started. The probe was not called Voyager for nothing, which translates as wanderer, eternal wandering through the dead corners of space. That's the unenviable fate of this device. Initially, the mission of the automatic space probe was to study Jupiter and Saturn. And indeed, it was Voyager 1 that first took sufficiently detailed images of these celestial bodies and their moons. But later, considering the excellent performance of the equipment on board the probe, it was decided to expand the mission. Thus, Voyager 1 went further, gradually passing Neptune's orbit, which is 30 astronomical units from the Sun. The probe rushed into the darkness of the unknown toward the Kuiper Belt and the edge of the heliosphere, which it successfully crossed in the summer of 2012. In any case, this is confirmed by the data from the instruments. You might be surprised, but what? Even with such an incredible speed, it took the probe 35 years to reach the notional boundary of the solar system. Right now, Voyager 1 is in an environment with an electron density expected from interstellar space. Thanks to this, we can hear the eerie hum emitted by this alien world. Of course, the probe delivered this information in a narrow frequency band, but scientists transformed the signal into a human audible range to see just how monotonously threatening deep space sounds. What explains Voyager's longevity? What single source continues to power it? The probe is powered by 3 radioisotope thermoelectric generators, which operate based on the decay of plutonium-238. The half-life of this radioactive element is about 90 years. At this point, the generator's power output is less than the initial level. Therefore, for some time, Voyager 1 will continue to send signals to Earth, but they will arrive less and less frequently due to the enormous distances. Even now, a message from the probe takes about a day to reach us. What do the messages from the automated station look like? It's still the same computer code consisting of zeros and ones, compiled in different sequences. But recently, in November 2023 to be exact, an unknown malfunction occurred in the device's operation. Voyager Odin began sending chaotic clusters of encoded information, after which rumors started spreading that the probe had been taken over by aliens. Scientists were unable to decipher this gibberish, so they attempted a remote repair of the device and succeeded. Fortunately, only one of the 3 onboard computers failed. It was the one sending the looped binary code to Earth. The problem was also that it took 45 hours to receive a message from the probe and send a response. That's why the first successes in bringing the Sense System devices online only appeared 4 months later, in March 2023. Here's another proof for you. If the probe really wants to live, science is powerless. What caused the malfunction? Perhaps there's still some kind of alien trace in this breakdown. National Aeronautics and Space Administration's information technology specialists found out that yes, there is, but not in the way the conspiracy theorists thought. The thing is, one of Voyager 1's computers was damaged by an energetically charged cosmic particle, which caused it to stop functioning properly. There's another theory. The equipment just wore out over the years, and that's why the malfunction happened. In the end, the space agency scientists solved the problem by rebooting the code, first splitting it into parts, since the memory capacity of the long-suffering probe's chips is too small for large-scale data transfer. Essentially, the specialists hacked the Voyager 1 system and reflashed it. You have to admit, after this incident, the phrase, "through hardships to the stars," started to sound much more meaningful. Where is Voyager 1 now? And what would we see if we had the chance to turn on the spacecraft's cameras? At the end of January 2025, the probe was at a distance of almost 25 billion kilometers, or 166 billion kilometers. 166 billion kilometers away. Yes? During the Voyager 1's production, Rebe Deford will cut it up amid Scholastica's prolonged betrayal in the 5th. 1,000 kilometers per hour. Mafia happened. Munich is powered by long-period comets. In general, the existence of this mysterious place has not been instrumentally confirmed and remains in the realm of hypothetical assumptions. However, indirect evidence suggests that this monstrous cloud is real. Voyager 1 has already passed through several spherical belts, the first of which was located between Mars and Jupiter. The mass of the asteroids in this belt is about 1/4 of the Moon's weight, but that's nothing compared to the Kuiper Belt, which is 200 times more massive than the first and 20 times wider. It's a real shame that Voyager 1's cameras have long been turned off to save power. Otherwise, back in 2004, when the spacecraft entered the Kuiper Belt, we would have seen dwarf planets like Makemake and Haumea with our own eyes. And not just as small bright dots, but up close, unfortunately. By the way, speaking of photos and bright dots, the most famous photo taken by Voyager 1 is called the pale blue dot. This photo was taken in 1990, and it shows Earth from a distance of 6 billion kilometers. Are you still sure you know everything about loneliness? At the same time, the spacecraft sent back a mosaic of 60 images, touchingly called the Family Portrait. The photo shows the Sun and several planets: Jupiter, Earth, Venus, Saturn, Uranus, and Neptune. Mars and Mercury. Due to their tiny size from a distance of 6 billion kilometers, they are indistinguishable at this scale. So, ahead on its path, the twin spacecraft Voyager 2 will also cross this monstrous sphere. Only in a different place is the Oort cloud located. It is considered an object of the solar system, though it is at the most distant reaches. Further beyond the outer sphere of the Oort cloud, our star has no influence on the surrounding objects. Its strength is not enough for that. How long will it take Voyager 1 to fly through the Oort cloud? At least 30 millennia. Just think about that unbelievable number. To reach just the inner edge of the Oort cloud, Voyager 1, traveling at 17 kilometers per second, will currently need 3 centuries. After that, it becomes completely clear that humanity can't dream of interstellar travel anytime soon. But what does this information give us, besides an excited imagination, since we don't know what could happen to the probe in such a dangerous place? The thing is, the Oort cloud is considered the source of comets that sometimes collide with our planet. Some astrophysicists believe that such catastrophic events are directly related to the periodic mass extinctions of Earth's ecosystems. But that's far from everything scientists know about the Oort cloud. Or at least they try to guess what amazing objects might be located on its inner edge. First of all, there might be a gas giant called Tyche, named after the Greek goddess, orbiting there. Good luck in the year. Konstantin Batygin and Michael Brown, astronomers from the California Institute of Technology, used computer simulations based on the movement of small celestial bodies beyond Pluto's orbit to confirm the validity of the hypothesis about the existence of Tyche. Will Voyager 1 really see this celestial body and confirm this assumption 100%? And what about the star Nemesis, the hypothetical celestial body orbiting the Sun at a distance of 100,000 astronomical units? What if it is also a real object, and not just a product of astronomers' imagination? The star Nemesis is also often associated with regular periods of mass extinctions of biological species on our planet. Astrobiologists believe that such events occur approximately every 26 million years, and that this celestial body is to blame. But how exactly? Followers of the hypothesis claim that when Nemesis approaches the Sun, it disturbs the orbits of comets in the Oort cloud, which then enter the inner solar system, and some of them eventually collide with Earth. It's no wonder why Nemesis is sometimes called the Death Star, but the Oort cloud isn't the limit of its travel ambitions. Voyager 1, of course, is not. If the probe manages to escape this dangerous, completely unexplored region, then it will have a very long journey ahead toward the constellation Camelopardalis. It will take Voyager 1 tens of thousands of years to reach Gliese 445, which is located in that constellation. If the probe does reach this destination, it will still pass by it at quite a distance, about 1.6 light years away. And still, if the cameras were pointed at the star Gliese through the lenses of Voyager 1, it would look like this. Moreover, it is assumed that there may be planets in the habitable zone of the star where life exists. Scientists make such assumptions despite the fact that Gliese 445 emits X-rays. Afterward, the spacecraft will travel toward the constellation Camelopardalis and will likely wander the Milky Way forever. One thing is certain, no gravity will ever lure Voyager 1 back into the near solar space. It will never return to Earth. It's interesting to wonder what else, besides the star Gliese 445, the wandering spacecraft might see in the constellation Camelopardalis. Are there any unusual objects there that could be studied? Gliese 445 belongs to the main sequence and is a red dwarf. But that's not the only object in this constellation. There are also blue supergiants, binary stars, and even spiral galaxies, such as New General Catalog 2403. Among the unusual objects, Campbell's Cascade stands out. It's an asterism in the form of a long chain of 20 stars, which can be observed with very powerful binoculars. Just imagine, Voyager 1 has a chance to see some of this with its own cameras. Anyway, the farther the twin spacecraft travel, the more valuable the information they send back to Earth becomes. After all, no one from our planet has ever been to these locations before. Even if we can't see what surrounds Voyager 1 right now, scientists can still use the decoded data to get an idea of the conditions in these distant, unexplored places. In short, the global community and all of us just have to closely follow the spacecraft's journey and pay attention to what it periodically sends back. When you look at photos from space, nothing seems strange or unusual. If these questions made you think, take another look at such pictures. Still, you don't notice anything. Here's a hint. In photos of objects in space, you almost never see stars. It would seem that the inky black background is perfect for bright spots of stars to stand out. But in reality, things are a bit different. The general public's lack of knowledge about why this happens gives rise to ignorant conspiracy theories, and even the suggestion that supposedly no one has actually been to space. Flat earthers shuddered, but all of this is just legends for the masses. But what about the undeniable fact that stars really aren't visible in such photos? It reminds me of Enrique Fermi's words, but where are they? Is that it? Let's start with a brief digression. The sky appears different from the surface of other celestial bodies or spacecraft than it does on Earth. It's no secret that the world outside planet Earth is absolutely not human-friendly. This characteristic can also be applied to what you will be able to see when observing it. For example, if we look at Venus from Mercury, its brightness will be at least 15 times greater than what we see from Earth from our point of view. And the sky of Amalthea and one of Jupiter's closer moons will be almost completely filled by the gas giant. So in this matter, everything is relative. As for stars, the most well-known example cited by conspiracy theorists who are convinced that everyone is lying is the following. A photo of the lunar sky from the American Apollo 8 spacecraft. Do you see any stars in it? Neither do we. The question is why? When this question was asked to the Apollo 11 astronauts Buzz Aldrin and Neil Armstrong, they answered as follows. They proved the fact that the landing on the moon took place during the lunar day, which lasts almost half a month. The thing is, National Aeronautics and Space Administration considered the lunar night too dangerous for landing, since the temperature at that time is extremely low and other conditions are not favorable for a successful human excursion onto the surface of the satellite. But what does the lunar day have to do with it? In the context of our question, let's give a small analogy. Imagine that you are standing on a playground and there is complete darkness all around you. Even if there are some sources of light in this darkness that are very distant and therefore relatively dim, it will be difficult for you to see them. For example, when there is no moon in the night sky, it becomes much darker and we can see more stars. But when it rises, its light outshines them, and only the brightest ones are visible. A similar effect can be observed with a campfire. While you sit by the fire, you can't see the stars, but as soon as you walk into the forest, the sky amazes you with a scattering of lights. If you're interested in the astronauts who first landed on the moon, here's an interesting fact for you. If they had moved, for example, into the shadow of the lunar module, or, risking their lives, had gone into one of the deep and dark craters, then even during the lunar day, they would have been able to see and photograph the stars from there. That's exactly the advice Armstrong gave to future astronauts, by the way, Michael Collins, who visited the far side of the moon. This happened when he, after his colleagues landed on the surface of our satellite, could see the stars quite clearly. The astronaut described his feelings in his memoirs. In them, he specifically noted that on the dark side of the moon, which is not illuminated by the sun, the darkness is so absolute that even a trained person feels uneasy. About the place where the lunar mass was at that moment as he flew by, Michael Collins could only tell by the absence of stars, guessing that they were blocked by the massive body of our satellite. I wonder if he heard the blood-chilling sounds that the equipment sometimes picks up in this location. Are there any technical reasons why it's impossible to find a single star in photos of space locations? The thing is, objects in space are photographed when they're illuminated by the sun. Otherwise, they simply wouldn't be visible. By using a short exposure, this approach is designed to capture bright celestial bodies or objects. For example, on the moon, priority was given to photographing lunar landscape details over other subjects. That is because of the short exposure. The faint starlight simply isn't captured, but Apollo 16 still managed to capture stars from the surface of the moon. This happened after installing an instrument for studying nebulae and stars, whose exposure was set to capture distant and faint objects. And here's what they got. The brightest celestial body in this photo is the Earth, illuminated by the sun. There are few stars in the picture because the lens only captured the brightest ones. If the exposure were even longer, there would be more stars. This is the main answer to the question of why stars aren't visible in photos taken from space. You can see how exposure length works in practice in this photo. The shorter these settings are, the brighter the objects the camera can capture, and vice versa. So to see something relatively dim, you need to set a long exposure, but you won't be able to capture both bright and dim objects well at the same time. Then here's another question. Why didn't American astronauts see stars in the lunar sky, not only with the camera, but also with their own eyes? The answer is similar to the previous one. The human eye, in terms of how it works, is somewhat similar to a camera. Take the pupil, for example. In the dark, it expands, and in bright light, it contracts significantly, just like a camera's aperture. So once again, let's recall Neil Armstrong's advice. To see the stars in the lunar sky, you should step into the shadow of a large object, such as the spacecraft, a mountain, or a big boulder. But has no one really ever photographed the beautiful starry sky near illuminated objects? There are plenty of such photos. If you dig through National Aeronautics and Space Administration's archives, you can find this kind of beauty. Since National Aeronautics and Space Administration took the picture, using a long exposure. As for the majority of photographs, their main purpose is usually not to capture stars, but rather objects or bodies of the Earth, the Moon, or International Space Station modules. And it's better to do this on the illuminated side, otherwise they will visually disappear. In general, the situation with photographs taken under light pollution conditions. For example, trying to photograph the starry sky against the background of bright lights is equally hopeless, both on Earth and on the Moon. Under such conditions, the faint objects will be hidden from view, and it doesn't matter that the objectively huge stars are billions of times brighter than the lights. It's still possible to photograph extremely distant stars. The other thing is that the quality of the photos will be terrible because with a long exposure before the stars appear, the other objects will be heavily overexposed. Another thing that makes us happy is that we have the opportunity to see space without ever having been there. For example, to observe such incredible beauty as a photo of our parent star taken from the International Space Station against the backdrop of Earth's clouds. And yes, all objects located in the vicinity of Earth, including Earth itself and the planets of the solar system, have been photographed exclusively from the daytime side. Don't be misled by the completely black lunar sky in the next photo. That's only because of the complete absence of an atmosphere. Everything else, as you can see, is beautifully lit. By the way, the same applies to the Tesla Roadster SpaceX electric car, launched into Earth's orbit on February 6, 2018. Just recently, on February 2nd, 2025, one of the amateur astronomers discovered a new asteroid located 240,000 kilometers from Earth. But the discoverer's joy didn't last long, even though the object was quickly added to the Minor Planet Center's catalog and given its own index. A few hours later, it turned out that it was a Tesla Roadster, still traveling along its orbit. Over the next 15 million years, we will make about 22 orbits, and with the Sun or Venus, 12. But again, if the Tesla Roadster, which was delivered to Earth's orbit as cargo by the Falcon Heavy spacecraft, was on the unlit side, we wouldn't have seen it. We wouldn't have seen it. We wouldn't have seen this.